Hello and welcome. My name is Saurabh Sirsikar and I am making a lecture series on design of experiment. This is my second lecture. In the first lecture, I have explained about the major steps to design an experiment and the basic terminology to understand design of experiment. So in this video I am going to explain mathematically how to analyze an experiment. So let's begin. If you have not watched my first video, then please go back to that video and then return here so that you will get a better understanding. And so there was this incident yesterday when my mom gave me sprouted beans, specifically moong usal we call it. So I observed that some of the beans were sprouted and some of them were not sprouted. So this became my motivation to study the process of sprouting of moong. So what is the first step? This explanation is given by my mom. So she says first you have to take moong, then you have to soak it in water for 6 to 10 hours. Okay, so basically she said you have to soak it overnight. So for me overnight means 10 hours, for her it is 6 hours sleeping time. So it differs. And then again the third step is after this period is over, then you have to cover it with a cloth. Okay, you have to drain it and cover it with a cloth for around 8 hours. So after 8 hours you will be observing that there will be the sprouts will be ready on the beans. So now I have done some variations and I have made this an experiment to study and you are going to enjoy it. And I have kept in mind that you can also perform this experiment at your home. So it is going to be exciting and you will love the maths part if you do perform it on your own at your house. Okay, so what I did was I selected factors out of this process. So let me write it for you. Factors which I selected were, so even before going to the factors, what is that we have to do? We have to select the outcome. So in this experiment our outcome is going to be maximizing the number of sprouted beans. I will write it down for you. Then comes the next step, that is selecting the factors. Now here my mom told me water, you have to soak the moong beans in water for 6 to 10 hours. That is, so we can take one factor as soaking time in water. Okay, for this factor I can have two levels. One will be 6 hours and other will be 10 hours. So this factor is a numerical factor because we can assign numerical value, as you can see 6 hours and 10 hours. Now logically we can assign this as our low factor. That means we can assign here a negative sign for this and this as our high level factor. So we can assign a positive sign for. So this is our low level, this is our high level for soaking time in water. Now second factor, I will number this as 1, and second factor which I have selected is cover with a cloth. So after soaking it in water, next step is covering it with a cloth and keeping it for 8 hours. So here I am not going to play with the time. Here I will just play with the covering of cloth. So I will say usage of cloth. So without cloth and with cloth. You understood? So without cloth, that means I will just take the moong which is soaked in water and I will not wrap it in a cloth, rather I will just keep it in an open container. Whereas when using this level I will cover it with a cloth. Okay, so let's say this is our low level, so I will denote it with negative sign, and this is our high level. Okay, so this was a numerical factor where you assign numerical values to the levels, and this is known as a categorical factor. Okay, so here you cannot assign numerical values, you have to give the category, that is without cloth or with cloth. Okay, so this can also be said as quantitative factor and qualitative factor. Okay, so these are some different words used in different books. So now you have understood that we have two factors and each factor has two levels. So now after getting this understanding, what we can do is we can plan the experiment. So we know that we have the number of combination as levels raised to the number of factors. So here we can see that there are two levels, and for this experiment there are two factors, so we can say this as 2 raised to 2, that is 4. So there will be 4 combinations or 4 treatments where we are going to try this experiment. So for that I will make a small table. So please understand that these are the two factors, and what are we going to measure after our experiment. So if we take 100 beans in one run, okay, so we will be having 4 runs. So I will give the numbering 1 2 3 4, okay. So after each run I will be measuring out of the 100 how many were sprouted, and what is our outcome? We want to maximize the number of sprouted beans. There will be some which will sprout and some which will not sprout, so that is going to be our outcome. Number of sprouted beans is going to be our outcome, okay. So now we have to decide the combinations. So as per standard rules, first factor, that is factor A, I have assigned as time. So soaking time in water is given as A, and usage of cloth I have denoted it B. So here you have to change the factor A fast. So minus plus minus plus, where minus denotes lower level and plus denotes higher level. Similarly for B you have to change the sign slowly. So minus minus plus plus. So designating this makes the experimenter understand the levels of factors which he has to maintain while doing the experiment. While execution of this experiment, you have to take care that you do not follow the standard order, rather you randomize this order. So what you can do is you can make 4 paper sheets and write 1 2 3 4 on each on those sheets, and then you randomly pick up one, and whatever comes first you give it first. Then if say this comes second, this comes third, and this comes fourth. So we have to do this exercise randomly. So after doing this experiment I got results like this. I hope everything is clear. So this is how you perform an experiment. Now comes the most important part, how to analyze the outcomes and how to develop a relation between the factors and the outcome, how the factors are affecting to the outcome. All this we will come to know when we analyze our experiment. So now comes the analysis step. So first step, I am going to draw the cube plot. So I will keep soaking time on the horizontal line, that is factor A. The lower level will be at the left and the higher level will be at the right. So this is our lower level, that means it is 6 hours, this is 10 hours. So cloth will be on the vertical axis, lower level at the bottom and higher level at the top. So what this is our without cloth and this is our with cloth, with and without. Now I have to plot this outcomes on this chart. So minus minus 52 for minus plus, this is plus minus 74 will be here, minus plus 62 will be here, and plus plus 880 will be. So this is known as cube plot. Now with the help of this cube plot I can analyze the main effect. For main effect I will use effect of A. So main effect of A, if I want to find, then I have to check what happens without, what happens in this region without cloth, what happens individual. So now first I will check for, let's see this with cloth. With cloth what happens is 80 minus, and without higher minus lower 74 minus 52. If I compute this 22 and this 18, so I get average as 20. Similarly, now let's see the main effect of B, that is cloth. So here studying main effect of B, we just have to focus on this 2, 62 minus 52, 6 hours soaking time. We will see what happens higher level minus lower level, and at 10 hours soaking time what happens 80 minus 7. So always higher minus lower 6. So the average is 8. So after doing this we came to know that the main effect of time is that on an average, due to time, if we move from 6 hours to 10 hours, 20 sprouts will be added, okay, and what is the main effect of cloth, wrapping cloth. If we go from without cloth to with cloth, we have additional 8 beans which are sprouting. So this is our study of main effect. One more way to analyze this results is drawing a contour plot. To make a contour plot, I have just copied this cube plot over here, and now if I want to plot 62 on this line, it would be somewhere here. So I will just join this point here to here, and if I want to find 74 on this line, it would be somewhere here in the middle. So I will join this point to here. So these are known as my contour lines, whatever I have drawn with the pencil. So if I draw parallel lines to this, be our contours. So with the help of contour plot, we can clearly see that if we want to maximize our output, we need to go from this direction towards this direction. That is, we want to go to higher levels of both the factors. So this is another way which you must remember. It is a new concept of contour plot. So previously you had studied cube plot, then you have studied contour plot. There is one more thing which is known as interaction plot. To understand the interaction between the two factors, so you must have noticed that I am writing main effect of factor A and main effect of factor B. Why? Because there is one additional effect that is known as the interaction effect. So there will be a combination of factor A and factor B. So to study that, first we need to see if there is any interaction between factor A and factor B. So what I will do is I will draw soaking time on the axis. So this will be minus and this will be plus. Okay, so minus denotes 6 hours and plus denotes 10 hours, higher level. So I will see that with the help of cloth, what is the reading? 52 and 60, 74. So 52 and 74. So if I draw a line to connect these, and now this is the line for with cloth. Similarly, if I plot for without cloth, then it is 62 at lower level and 80 at higher. So if I draw a line, 60, draw it with the blue line. So here you can observe that these two lines are approximately parallel to each other, which denotes that there is no as such interaction between factor of time and cloth. Okay, so similarly if I plot for cloth, keeping this on the axis, lower level and higher level over here. So for shorter duration of 6 hours, we can see that it is 52 without cloth and 62 with cloth. So I will join it with the black pen, and this is for the shorter duration of 6 hours. And if I plot with the blue pen of the longer duration, this is 74, and with cloth for longer duration, what is the reading? It is 8. So if I join this again, I can see that these two lines are approximately parallel to each other. So we can say that if these charts are known as interaction, so in the interaction plot we can see that there is no such interaction between the factor A and B. So here in this video you have seen that the analysis can be visualized by 4 major things. That is, first is the tabular form, second is the cube plot form. Okay, this is the cube plot, this is the contour plot, and these are the interaction plots. Okay, so very easily you can understand the data which is analyzed with the help of these 4 charts. So now let's jump into the mathematical part of the analysis of the experiment. So here you can see that I have redrawn the cube plot, and I am going to write an expression in terms of y is equal to f of x. Now here y is the response, that is, now we can say y is the prediction of response. So that means y will be predicting the number of sprouted beans, and it will be dependent on the baseline plus the impact of factor A plus the impact of factor B. So you might ask, from where did I get these numbers? So we will come to it later. First we will see if this equation is correct, if it is able to correctly predict the number of beans that are going to be sprouted. Okay, so now let's focus on this setting, that is when we are using soaking time of 6 hours and we are not using any cloth, this equation should predict somewhere near this outcome. So if we try to use this equation, let me show you how you are going to use. So I will write it here now. Y is equal to 67 plus 10 into XA. Now here XA will be -1, because here we on this cube plot we can say this is -1 and this here is +1. Similarly on the vertical axis this is -1 and this is +1. Okay, so these -1 and +1 are coded values, so I will write here, because we are on the lower level for XA, that is factor A lower level, that's why we will write here as -1 plus 4 into XB. So as we are predicting for this and without cloth, so without cloth is denoted by -1. We will write here minus. So if I simplify this, it will be -10 minus 4, so it will be equal to 53, so which is very close to what we have actually attained. So our prediction is very close to the actual outcome, so we can say that this equation satisfies in this condition. Now for confirmation, let's also check when we have higher soaking time and we are using cloth. Okay, so there we can substitute y equals to 67 plus 10 into, now here both the factors are at higher levels, so I will be substituting +1 for A and +1 for B. So this will become 67 plus 10 plus 4. So if we calculate, it will be 81. 81 is very close to 80. So we can say our predictive model is working. Okay, now let me show you how did I get this predictive model. so here first let me write here what is y. It is the predicted sprout. Okay, so this is the outcome. This is known as the baseline, this is known as the effect of A, and this is known as the effect of factor B. So now you know what each term stands for. Now let us see how we calculated this. So how to calculate baseline is simply you have to take average of all the 4 terms on the cube plot. So baseline will be equal to 52 plus 74 plus 80 plus T2 divided by 4. So if you calculate this, you will get 7. Okay, now let us see how did we get the coefficient as 10 as an effect of A. So you know that how we calculated the main effect of A. We will always take from high to low. So for with cloth we can say it is 80 minus 62. So higher level minus lower level minus and comes to bean, and for without cloth will be higher minus lower. So 74 minus 52, that will be equal to 22. So we take an average. So average of 18 and 22 is 20. Okay, I will write it. So you will say we got the effect of A as 20, but in the equation there is a 10. So let me explain you how it is 10. That is because we have divided the main effect by 2 and we have reported this value divide by 2, we have reported this 10. Okay, so why we have divided by 2? Because here we can see that we are jumping 2 units from -1 to +1. That is, if we increase the time from 6 hours to 10 hours, we get 52 to 74, but we are jumping here by 2 units. Okay, from -1 to 0 is our first unit and 0 to +1 is our second unit. So that is why we are dividing by 2 and we are reporting as 10. So similarly, if we check the effect of cloth, so here also always remember this, that we are going to go from a higher level to a lower level. So long soaking time, what is happening at long soaking time? We can say 80 minus 75. Higher level minus lower level be 80 minus 7. For short soak time, what are we having? 62 minus 52, higher minus low. Calculate this 6, 10. We take average of this, we get 8. But so this average is 8 and we are going to divide it by 2. Why? Because here also we are jumping 2 units from -1 to 1. -1 to 0 is one step and 0 to 1 is another step. So we are going to divide it by 2 and it comes to be 4. So we are going to report this value in the equation. So here we can see 4 into xb. So I hope that you have understood how to make this equation. The baseline number we get by taking the average of these 4 outcomes. For xa we have to divide by 2 the average effect of time, that is factor a, and for this coefficient of xb we have to divide the average of the cloth effect by 2. So here we get the 4. Now you may ask, sir, why do you need to have this kind of a predictive equation? Let me tell you the importance of that. If I want to find what is the number of sprouted beans at when I am soaking it for 8 hours. So how will you do that? Simply you will substitute this xa is equal to this value, that is 0. Why? Because -1 is assigned for 6 hours and +1 is assigned for 10 hours. So for 8 hours you will be assigning value of xa is equal to 0, right? So this coefficient will be 0. If I want to predict what is happening at time is 8 hours, so at that time this equation will become T7 plus 10 into 0 plus 4 into, so if we are using the cloth then here we will put +1. If we are not using the cloth then we will put -1. Okay, so this way you can predict 67 plus 0 minus 4. So 63 beans will be sprouting if 8 hours and without cloth setting is used. Okay, so now you understood why this mathematical equation becomes important. Okay, so with this example you have now learned to analyze how we can perform an entire experiment and we can form a mathematical model which will be using to predict various settings in between. Okay, so thank you for watching.